Hello, and welcome to the Esri GeoDev webinar series. This series of webinars is a continuation that we created in the hopes of engaging in developer-related topics and discussions in between dev summits. We hope you get as much or more out of it than you anticipated. Now, we would like to introduce you to today's webinar, Building Native Apps with ArcGIS Runtime. Before we get started, I'd like to go over a few items so you know how to participate in today's event. We've taken a screenshot here that you see of an example of the attendee interface. We've also attached a handout for you to review in case you are unfamiliar with GoToWebinar. You should see something that looks like this on your own computer desktop in the upper right-hand corner. You're listening in using your computer's speaker system by default. If you would like to join over the phone, just select telephone in the audio pane and the dial-in information will be displayed. You will have the opportunity to submit text questions to today's presenters by typing your questions into the questions pane of the control panel. You may send in your questions at any time during the presentation. We will collect these and address them during the Q&A session at the end of today's presentation. I would now like to introduce you to Nick Furness, Product Manager for Runtime SDK for iOS with Esri, and Rich Swap, Software Developer Engineer for Runtime SDK for .NET, also with Esri. Nick, let's get started, shall we?
All right. Hi, everybody. Thanks for taking the time to join us today. We're going to be talking to you over the next 45 minutes about the ArcGIS Runtime, particularly building native apps with it, and how you can take advantage of it, what it does, what it can bring to the table for you. So let's just take a look at what we're going to cover real quick. We'll start off with an overview of the runtime, and then we'll dive right into some code where Rich will take you through actually seeing the runtime in action. We'll do a little bit of discussion about using the runtime in an offline capacity. More information on that in the next few slides about why that's relevant. And then we'll dive into some best practices, some good ideas when using the runtime, and then that kind of dovetails nicely into your adoption of the runtime, how you can get started with it, how you can introduce it to your own projects. And related to that, of course, is a coverage of the help and resources that are available to you. And then we'll finish off with the road ahead, just a couple of slides on what's coming really soon in the runtime in the December release, and then what's planned for down the road. That covers the webinar. For the rest of the day, it's GIS Day today. So go ahead, check out gisday.com, see if there's any events near you that you might want to go ahead and get involved with. So let's dive into what the runtime is. So it's our developer product for building native applications, applications in particular that are part of the WebGIS pattern. That is, they connect to services and web maps and the like, and act as clients to those services. So pulling feature data, base maps, and the like onto devices. Now, those devices could be mobile devices like Android or iOS devices, an iPad perhaps, but they could also be laptops, a Windows laptop, a Linux laptop, Mac OS. They also incorporate some offline capabilities. So I talked about the WebGIS pattern, but it's important in a lot of scenarios to be able to take a lot of the work that you're doing in that connected WebGIS environment and be able to do it in a disconnected way. We'll look at some of the ways to do that, the benefits of doing that, and the way that actually bleeds into some other decisions that you might want to make about using the runtime. We have SDKs for .NET, which includes Xamarin for cross-platform work, and looking at cross-platform, we also have a Qt SDK. And then if you want to be, if you're a specific developer for a platform like Android, iOS, Mac OS, or Java, then we have SDKs to cover you too. So understanding what it is, let's look at what it does. From the ground up, it's been built for very high performance on-device 2D and 3D mapping. As I mentioned, it's part of the WebGIS pattern, so it connects to ArcGIS Online and Portal and ArcGIS Server. It consumes web maps, but not only consumes, it allows you to edit and save them as well. And as part of that, of course, to pull the data down, we make use of feature services, map services, and image services that all go together to build your map display, or the analysis that you want to do. You can pull data down from these services without even putting them on a map if you need to. And to go alongside that is access to service-driven geoprocessing. So you can publish your geoprocessing tasks, or maybe we have tasks available on ArcGIS Online for you to consume, and the runtime can consume those. Now, in addition, we can do a lot of stuff offline. We can read local data, mobile map packages generated by ArcGIS Pro, tile packages. We can do geocoding and routing completely offline on the device using network models and Locator stored on the device. And we can do very fast geometric operations like buffers and unions using the runtime and using the full power of the device. Now, I talked about connecting to web maps. You can take those web maps offline as well. So let's say you want to connect to a web map, do some work with it. You're going to enter an offline scenario. You can take the whole web map offline using some simple API calls, pull that data down, be able to work with it, and even then synchronize edits from that web map back up to the service when you're reconnected to the network. So how does this all work? Well, it's all built around a C++ runtime core. That's carefully built for high performance, and then on top of that are SDKs for all these various platforms. The C++ runtime core really determines what functionality is available to each of these SDKs, and these SDKs are now very thin layers on top of that. This helps to ensure that we have the same capabilities across all the APIs and SDKs. The runtime core governs that. But the focus of these thin layers is to provide a very tailored SDK environment to a developer for that platform. So for example, if I'm an iOS developer and I look at the Runtime SDK, I don't feel like I'm looking at a generic SDK. I feel like I'm looking at an Objective-C or Swift SDK that takes advantage of the platform. For example, for credential caching on iOS, we can take advantage of the iOS keychain. And each of the SDKs makes use of these specific tailorings to feel like a really native SDK for that particular developer. So I'll just run through the SDKs very briefly. The .NET supports C#, Visual Basic, and XAML. There's Visual Studio integration, including project templates. Of course, you get IntelliSense, and there's a NuGet repository. There's also a NuGet package available. And with all this, you end up being able to build cross-platform applications for Windows, iOS, and Android. So that includes Xamarin iOS, Xamarin Android, and Xamarin Forms, as well as WPF and UWP. This slide actually covers two SDKs, one for iOS, one for macOS. They're so similar, I've pulled them into one slide. They both support Swift and Objective-C. They both have Xcode integration as far as Apple allows it. Unfortunately, that means we can't have project templates very easily, not in a maintainable way. Documentation, autocomplete, there's playground support, and we have CocoaPods available to you also. For Android, we support Java and Kotlin. We have a bin tray repo. You can use Gradle tools and integration with Android Studio and IntelliJ to install that. And similarly for Java, we support Java and Kotlin. Again, standard dependency management, all the things you'd expect to see. UI development integration tools, the ability to use some of these tools for UI development as well. Last but not least is the Qt SDK. So this supports C++ and QML. Full integration with Qt Creator. And this allows you to build cross-platform apps for Windows, Linux, Android, iOS, and Mac OS. Now, if you're not familiar with it, maybe take a look at esri.com/appstudio. The Qt runtime is the runtime that sits behind App Studio. So App Studio is a product we have for template-driven. It's basically a kickstart to get some runtime applications, cross-platform runtime applications built. We won't go into that today. It's beyond the scope of this webinar. But with that understanding of what the runtime can do for you, how it's architected, I'll hand over to Rich to dive into some code and show you it in action.
All right. Thanks, Nick. So yeah, now that you guys have heard a little bit about what the ArcGIS Runtime is and what it can do, since this is a developer webinar, we thought it would be good to dive right into some coding. So for this demo, I'm using an application called Xamarin Workbooks. And this is just something that allows me to mix nicely formatted text content like this and code snippets like down here, and then actually also run those code snippets and kind of iteratively build up some functionality, while then you also have the descriptive text to help you follow along. Now, the code samples that I am going to go through here are written in C#. and they leverage the ArcGIS Runtime SDK for .NET. But as Nick was saying, these same capabilities are available across all the runtime SDKs, regardless of your platform of choice. They're just going to be syntactically a little different from platform to platform, so that it matches and feels comfortable to the platform that you're targeting. So first, we want to build up an application, and we want to leverage the runtime. Now, naturally, the first thing we might want to do is show a map, right? So for that, in the runtime, we actually have two objects. So we have a map view class, and that's essentially our UI object. So that's the class that we're going to put into our layout. So if I'm targeting Windows or I'm targeting Xamarin Forms, then I'm going to put that in my XAML layout. Or if I'm building a native iOS application, then I'm going to bring that into my storyboard. Or if I'm doing native Android development, I would want to put that in my XML layout, right? So that's essentially for inclusion in our presentation layer. Now, the other object we have there is the map. And that's essentially a data object. And that defines the geographic content that we want to display in our map view. So in this way, we have a separation at the most fundamental level in the runtime of presentation layer versus business logic. So if I'm following that application architecture in my application, whereas I have a separation of presentation layer and business logic, then the map view lives with my presentation layer and the map goes with my business logic. Now, looking at how we can actually use this in code, you can see I'm instantiating a map. In this case, initializing it with a URL that points to a web map. For those of you, in case anyone's attending who's not aware, a web map is just a map definition that includes a list of web services to display in the map. I could also initialize a map with discrete web services, or I could choose to initialize it with offline content that's available locally on my device. Or you can mix and match those approaches. In this case, I'm just using a web map. Then I simply instantiate the map view, plug the map into the map view, and then add that map view to the UI of my application. So when I run this, we should see that web map displayed in our application that we're building up on the right here. So that's the basics of how we get 2D geographic content in our app. Now, one thing that the runtime's also really good at and makes really easy to do is displaying geographic content in 3D. And that follows a really similar pattern to the map view and the map. It's just a bit of a terminology difference. So instead of map view and map, for 3D, we have scene view and scene. So looking at the code to show a 3D map, all I need to do is instantiate a scene, much in the same way I did with the map object. And then in this case, instead of initializing it with a web map, I'm taking advantage of this convenience enumeration, just specifying that I want to initialize it with one of the ArcGIS online base maps that's available. Then instantiate the scene, instantiate the scene view, plug the scene into the scene view, and then add that to the UI of my application. And that's going to overlay on top of the map view that I already have there. But you can see just that quickly with essentially the same pattern that we've used for the map view, I have a nice 3D globe, a three-dimensional view of my geographic content. So I'm going to go ahead and just remove that scene view from the UI of my application and continue building up the rest of the application just based on the map view. So now that I have my map initialized, naturally as I'm building this up, I'm going to want to add additional geographic content to it. In case any attendees aren't familiar, in the runtime and in the ArcGIS platform more broadly, we generally manage geographic content within a map as layers. A layer, quite simply, is a geographic data set coupled with some cartographic visualization properties. Now, taking a look at how this looks in code, we can see I'm instantiating a feature layer and specifying a URL to a feature service. Now, don't worry too much as to the particular type of layer I'm using. Suffice it to say that there are a number of different layer types surfaced in the Runtime SDKs, and that just reflects the difference in underlying data sources that the runtime supports. So since those underlying data sources intrinsically have different capabilities, we bubble that up to the API surface in different layer types so that you, as the end developer, can fully leverage those different capabilities that the data sources provide. So once I've got that feature layer initialized, then I have the option to modify its appearance. So this is a layer, so it includes some default appearance properties, but the runtime allows me, as I'm building my application, to modify that appearance such that it better suits my particular application. In this case, I'm just modifying the transparency a little bit. But you as the developer, if you need to, you can do similar and modify it slightly, or you can make wholesale changes to the appearance to make it work well within your application. Then, so to get it on the map, I simply add it to the map object. Again, the map, as opposed to the map view, is the repository for our geographic content. So I simply add it to the collection of layers that map object manages. So I've run that, and then you see I have this feature layer pointing to a world rivers feature service displaying on the map. Okay, so great. We have our map initialized showing in our application. Now, since we're using the runtime, it's very likely that we are doing some mobile application development. And very commonly in mobile application development, we need to display or otherwise take advantage of the user or device location. As far as display, the runtime makes this really easy. We have this location display property available off the map view. And to turn that on, I just flip this is enabled property to true. So if I run this, that's spinning up my location on my device, in this case, my PC, and there we see it appears on the map. So that's good. We can see now where within the world my device is. But it's not very specific. We've got a pretty zoomed out view of things, right? So to get a more relevant context for where my user location is, I want to see a tighter view around that location. I want to zoom to it. So for zooming to areas of interest and for navigating the map more generally, the runtime provides a method called setViewpointAsync. And that takes an object called a viewpoint. A viewpoint is just simply an object that represents geographic areas of interest. There's a number of ways a geographic area of interest might be specified. So in the Runtime SDKs, we encapsulate that in an object called viewpoint that allows you to specify it using any one of those ways. In this case, I want to center my map view on the user's location and zoom into it. So I'm going to instantiate a viewpoint here, looking at the code, specifying my user location. So that's drilling into this location display object again and getting the location that is shown on the map from that programmatically. And then also specifying that I want a map scale of 1 to 20,000. Then simply call that setViewpointAsync method that I mentioned, passing in that viewpoint, along with a couple other optional parameters that allow me to tweak the speed and behavior of that zoom in animation we just saw. So now we can see I'm zoomed in nice and tight to the current location. So that's good. The user sees where they are, but naturally they're going to want to find out where other things are that may be of interest to them. Very commonly, they may have an address or the name of a place of interest, and they want to actually get the geographic location based on that information. So for that, the runtime provides an object called the Locator task. And looking at how we use this in code, we simply call a factory method called createAsync to instantiate it. Once again, I am leveraging a web service and specifying that during initialization. In this case, this is the ArcGIS Online World Geocoding Service. Then I simply call the geocode async method to actually do an address or place of interest lookup. In this particular case, I am just trying to get the location of Santa Monica. And then once I have that result, I want to navigate to it on the map. I could do any number of things with that result I get back. In this case, I'm just going to use that set viewpoint async method that we've already seen and specify that my area of interest is the extent of that geocoding result. So there we have looked up that location and zoomed off to it, and you see we're looking at Santa Monica, which is good. We're looking at the general area that corresponds to the geocoding result, but we don't see any particular feature on the map. So then how do we actually get that on the map? Well, I mentioned that for geographic content, we have the concept of layers. But layers, getting a little more specific, are generally for persistent geographic content. So these are data sets that have a lifetime outside the scope of the particular application that you're developing. By contrast, for things like geocoding results or routing results or geoprocessing results, for, in general, operations that are being done by the user on demand within the context of an application, oftentimes the results we get back from those we can just discard when we're done with them. They're transient geographic content. And for that, the runtime has something called a graphics overlay, which is basically the equivalent of a layer, except that graphics overlays are intended to house transient geographic content. And within graphics overlays, we have a collection of graphics, which are the actual individual transient features we want to display on the map. Each graphic consists of a map geometry that could be a map point or a line or a polygon, and it also consists of a symbol which specifies the visual appearance that we want that geometry to take on the map, colors, line thickness, styles, etc., etc. So looking at this in code, here, first we're initializing the symbol we want to use to symbolize our geocoding result. I know that this is a point, so I'm using just a marker symbol. I'm saying I want that to show as a circle. I'd like it to be dark gray. And then I'm also specifying an outline for that circle using the symbol I have initialized here. And then once we have that symbol, we've already gotten our geocoding result. So then I can go ahead and instantiate a graphic, passing it my geocode results display location and that symbol that I want to use for the graphics appearance. Then, as I mentioned, we need a graphics overlay to actually house that graphic. So we instantiate that there, add the graphic to the graphics overlays graphics collection, and then add that graphics overlay to the map view. That's all a really long-winded way of saying this is how you put points, lines, and polygons on the map. Okay, so now we have the user's location. We have we've looked up a place of interest. Very commonly in this scenario, then we want to figure out how to get between those 2 points, routing, right? So for that, the ArcGIS Runtime offers an object called the route task. Very similar to the locator task in naming and in how it's used. There's actually a lot of these task objects in the runtime, and these are the pattern we use generally for operations that you run and get results for. So for instance, we also have a geoprocessing task. We have an export tile cache task for taking tiles from map services offline, et cetera, et cetera. There's a whole bunch of them. If you guys do much runtime-based development, you'll become very familiar with that. Now, taking a look at the code, don't worry too much about this first part here. That's just for authentication, since I'm using a secure web service. The part that's more of interest is here, where I'm initializing my route task, instantiating it, again using a factory method, again specifying a URL. This time I'm pointing it to the ArcGIS World Route Service. And in this case, I need to specify some parameters for my routing operation. At a minimum, I need to specify a start and endpoint, right? And that's all I'm specifying here. But there's a lot more power here than I'm going into. Really, with all these things, I'm just barely scratching the surface of the capabilities of the runtime. All these things have a real GIS power and depth to them. So then once I have my parameters set up with my start and end point, then I simply call the solve route method, pass the route parameters to it, get my result, and then similar to what I've done before, create a symbol that I want to use to show that on the map, put it in a graphics overlay, and last but not least, zoom to it. So actually run this, and that's calculating the route now, and then as soon as it gets that back, there we see it plotted on the map, and we have zoomed out to that route. Now, last but not least, I've used capabilities leveraging online web services. As Nick mentioned, the runtime also offers a whole host of functionality that can be run locally on the device, independent of a web service. Many of those capabilities are surfaced as geometric operations in the ArcGIS Runtime's geometry engine. In this particular case, I want to buffer the route we've just generated, as that's a common operation. I might need to perhaps find people within a certain radius of that route to notify them, or there could be many reasons. But looking at the code, we can see it's really very simple. I have off of geometry engine a static method called buffer geodetic. I pass it the geometry I want to calculate the buffer around, and say that I would please like this buffer calculated for a distance of 5 miles. The rest is really a repeat of, again, symbolizing it, creating a graphic, and then placing that in a graphics overlay to show on the map. Now, if I run this, we see that since that's running locally on the device, that buffer's been calculated and plotted on the map almost instantly. So that's really all I have for my Whirlwind ArcGIS Runtime 101. Now, I think I'm going to throw it over to Nick to show that as opposed to being .NET code, we also have another, the runtime being cross-platform as it is, we can use other languages and how that the runtime feels native to those other development platforms as well.
Sure, thanks, Rich. So yeah, I'm here. We're looking at something that's going to go through some very similar stuff to what Rich just showed. This is Xcode, open on the left-hand side. You can see my Xcode project there, and this is written in Swift. So just to show there's no smoke and mirrors here. On the right-hand side is the iOS simulator. So I've already fired up the app. And what we did was we've got a map view, which is the UI control. We've created a map object and set a light gray canvas vector. So you can see we're doing the same things as Rich did, but with slightly different syntax. This syntax feels very natural to an iOS developer. So if I click on the location button here, we're going to start the location display. And you can see the application goes ahead and takes me to my location. So this is using iOS's native location stuff. Now we've got a locator set up, and we're just going to do a geocode. Now, whereas Rich has the await keyword in C#, in Swift, you handle everything with callback blocks. So when we do the locator geocode for Santa Monica, the results will come back in here. We're going to look at the first results extent and set the viewpoint to that. And then we're going to look at the first results location and add a graphic to the map to represent that. So let's geocode that. And you can see the map zoomed to the extent of Santa Monica and then put a placeholder on the map for it. Now, I'll just fire off the route here. And in the code, we can see that we're doing pretty much what Rich did. So we set the stops on the parameters here. I've gone ahead and set the output spatial reference to match the map, but the runtime will typically handle that. And then we just solve the route with these parameters. And again, here's the callback block. And in the callback block, I'm taking the first result and just getting the geometry, adding a graphic to the map for it, and then zooming to it, expanding by a factor of 1.2. And the last thing we want to do is just take that route result and buffer it. So we're using Geometry Engine Buffer. This is a non-geodesic buffer, just to show a slightly different function being used in the Geometry Engine. We create a graphic, we'll overlay that and add that to the map. So when I click on that, that gets created and added almost immediately. I just wanted to show that as a quick parallel to Rich's demo, and now I'll hand back to Rich.
All right, great. Thanks, Nick. So that was a whole bunch of functionality, and it touches on some pretty important capabilities of the runtime. So I just want to quickly go over what all we just saw there. So first we saw maybe the most fundamental capability: how do we display a map, and how the runtime separates that into presentation layer and business logic with the map and map view. Then we saw how easy it is to display 3D content using a similar pattern with map and map view, just using scene and scene view. Then we saw how after we have a map initialized, we can still add additional layers of geographic content to that map simply by manipulating the map's layers collections. And then we also saw how we can get a hold of the device or user's location and show that on the map, as well as get access to that and use it as input to other operations. We saw how we can move around the map using the map views set viewpoint async method. And then getting into analysis a little bit, we saw how the locator task makes it easy to do geocoding. Now, I didn't show some of the additional capabilities of locator task include reverse geocoding, so that's getting an address given an input point, or very critical to good application development, the locator task also supports getting suggestions given a partial input string. So this is basically to get to drive autocomplete capabilities in an app. So as a user's starting to type a place name or an address in a search box, the locator task suggest functionality can be used to populate a list of places that they might actually be looking for. We also saw how we can do routing using the route task. And then last but not least, we saw a little bit of offline capability using the geometry engine, just buffering the route we had generated. Now, speaking of offline, in my demo there, and Nick in his demo, leveraged primarily online web services for most of the functionality. But as Nick mentioned, there is really a broad range of capabilities that the offline has for performing tasks offline in a disconnected way that's not dependent on network connectivity. And now I think that's kind of an important part of the runtime in general, and something that is really unique to the runtime and can be quite advantageous for you to take, for you to leverage in your applications. So I want to just spend a little bit of time talking about that and showing you a little bit about it. So first of all, what can you actually do in an offline manner with the runtime? You can, of course, display map content. That includes base map data, so that could be pre-baked vector and image tiles. You can display raster data. You can display feature data as well. You can also perform editing in an offline manner. Now, this does need to be backed by a service, but you can essentially take data offline, disconnect from the network, edit it offline, and then sync those changes back with service. You can also do a whole range of analysis offline in a disconnected manner. That includes querying feature data, performing geocoding and routing operations. So the same operations that Nick and I just showed in our demos can be done offline, talking to locators and network data sets stored locally on the device, as well as geometric operations using the geometry engine. And the workflows that support offline capabilities are flexible. So there is a range of capabilities that can be done in a fully disconnected manner. So perhaps with data that is sideloaded onto a device, or perhaps downloaded once at initial application initialization. Or there's a range of capabilities that are designed for intermittent network connectivity scenarios, which are obviously really common when you're doing mobile application development. You have to deal with network connectivity coming in and out. So as opposed to talking about that more, I just want to show a quick demo to give you an idea of how the offline capability can be advantageous. So here I'm going to bring up two, these are Android emulators. Looks like there's a little rendering problem around the border of them, but rest assured, these are Android emulators, and the application that's running in them is built with our Xamarin Android bits from our ArcGIS Runtime SDK for .NET. And the application on the left has essentially all the same functionality as the demo that you saw from me and Nick. So this is going to load a map, show the user device location, find an address, and calculate a route, and then buffer that. But it's doing so using the same web services that you saw in the demo. So I click this load map button and kick that off. And we see maps rendered, got the location. Now I've cut out the zoom animations because we don't want to add to the running timer here. But see, you can see now we're doing the route and we have the buffer, and then the whole thing, the performance has really been quite good. It's only taken about 16 seconds. Now I have the same application, but all those capabilities, the map content, the geocoding, the routing, are performed offline. So I'm going to kick that off, and let's see how that compares. There it's performing the geocoding and the routing. And it looks like on this particular run, it's actually going to be quite comparable. I think having both emulators running is causing some issues on my machine, but many times, I've run through this demo a number of times, the offline capabilities will run sub 10 seconds, and the connected version can take a bit longer than it did here, as that's subject to network connectivity. But anyway, that hopefully gives you the idea of some of the differences there. And with that, I'm going to throw it back over to Nick to drill in a little bit on best practices with the runtime.
Thanks, Rich. Right. Okay. So yeah, we'll take a look now at some of the from what we saw from the last few demos and so on. We can take away some best practices. We're going to focus initially on performance and availability. Now, I've mentioned how the runtime is built from the ground up for high performance. That's really a function of wanting to deliver the best capabilities to you as a developer using the ArcGIS platform, so that when you decide on using the runtime, you can be confident that we've put in the engineering effort to make sure that it works well. But in addition to that, there are aspects that feed into that. So Rich was just showing there and talking about online versus offline data. Now, it's always a balance. So what you can do with offline data is you can take data, geocoders, network models, and sideload them onto the device, have them running and stored natively on the device for really highly interactive performance. It's really driven by there being no round trip to a server to pull that data down. Otherwise, as you're panning around a map, you're constantly having to make requests across the wire to get information from another server, which may be loaded by a lot of other users hitting it at the same time. If that data is just on the device, you can focus on getting that device to your screen and making the map interactive much more quickly. But there's really nothing wrong with using a hybrid approach either. The runtime allows you, it doesn't force you into an online or offline mode. It allows you to mix and match what you need as you need it. So, for example, if you've got operational data that's edited frequently and constantly updated, but you have, say, base maps that are suitable for your entire workforce, you can go ahead and just take the base maps offline, take them offline once, put them onto a device, and make use of them there while staying connected to your operational data online. You might want to take everything offline, but there's absolutely nothing wrong with considering a hybrid approach. And what drives that decision making is going to be the qualities of your data and the availability of your network. So, for example, an easy one is, do you need to edit the data? Right now, if you need to edit it, then you have to be connected at some point to a service that feeds that data. You can opt to take a section of that data offline from the service, edit it, and synchronize it back. But if you're not going to edit it at all, that's a good candidate, perhaps, for completely sideloading it onto a device. Will many people be operating on the same data? And if it's not editable, then perhaps that's a great opportunity to generate that package of data once, like I was talking about with the base maps, and put it onto multiple devices, even if it's operational data. If your data changes frequently, for example, what that means is, and you're editing and syncing, those synchronization packages, which pick up all the differences since you last synced, will be bigger than if the data is edited very infrequently. Now, that may not be bigger to a degree that makes an impact, but it might, if it's very frequently edited data, you might want to think about trying to organize your workforce to synchronize when they're on a good Wi-Fi connection or a good network connection of any kind. Again, it's entirely dependent upon your use cases, your workforce, the nature of your data, how it changes. More practically, what's your network really like? Not what have you been sold, but what's it actually like? So this kind of gets into a message I always try to give. It's always worth testing on real devices in the field as well to get real world sense of how things are going to work. But how fast is the network in the field, and is it patchy? Is it really as consistent as they say, or are there going to be areas where it's not going to work so well? So you're going to change the way you use our offline capabilities based off that. For better performance, do work on the device. Now, Geometry Engine takes over the capabilities of geometry services from the past. In fact, we recommend solely using Geometry Engine now, rather than doing a round trip and having a service do stuff. So much functionality is available on the Geometry Engine, and it's tailored to take the best advantage of device capabilities. We've talked about offline data, largely involving avoiding round trips to the server. A little point of implementation, we talked about some graphics overlays. We were just putting a couple of things into each of them here. So this doesn't really matter, but if you're starting to put lots of data into graphics overlays, or if you need highly interactive use of the graphics overlay, and again, over the webinar, some of the slick performance doesn't really come across on the screen sharing. Bear in mind, graphics overlays can operate in two rendering pipeline modes, dynamic and static. Just be aware that there's a difference. If you're starting to really seriously put a lot of data or interactivity into your map, you might start to notice a difference in a requirement to pick one or the other. And that takes me into what's it going to take for you to get started with the Runtime SDK. Where do you begin? Well, everyone should begin at the developer's site, developers.arcgis.com. If you've got an organization with ArcGIS Online, you can log in with using that, or you can sign up for a free developer account. You get 50 credits a month for free to do any kind of dev work you want. Each SDK, if you click on the APIs and SDKs section here, you'll see them listed. We go to each SDK has a section like this with guides, reference docs, and links to forums, as well as a way to download the SDK. The guides are really useful. They kind of step you through installation and various high-level concepts of the APIs. And there's also sample code. The samples are linked to from the developer's site, but they live on GitHub. They're open source projects. Where possible, we've released them to the appropriate app stores as well. and they show how to focus in on a specific aspect of runtime functionality. For example, how do I do a geocode? How do I do some routing? And there are toolkits that are being built out over time to supplement each SDK. I'll talk about that on the very last slide as well. I just want to quickly mention dev labs. These are step-by-step labs, typically less than 20 minutes, typically much less than that, honestly. They take you through building out a specific bit of functionality to help teach you something about the platform, about the runtime. For example, how do we create a 2D layer? How do we display a web map? How do we do some search and geocode? So lots of the stuff that we've been showing you, but in a self-led, step-by-step environment. You don't need any experience, and you can do these in any order. They're very useful. We're expanding these all the time as well, very actively expanding these. And I just want to mention example apps. So these are different to samples in that these are kind of a real-world use of ArcGIS Runtime in a real application that one might build and put in an app store. So not just simple targeted sample that says, here's how to geocode. It's, I've built an application, I need geocoding in it. How am I going to build that into the UI? How is this application going to work in an asynchronous way using the best practices for that platform? Now, you can use this to kickstart a new app. You can take bits and pieces of it, and they're all open source on GitHub as well. You can get to them from the developer's site. There's an example apps link at the top. So how do you add the runtime to your existing app? The guide docs are a great place to start. Step-by-step instructions for adding it to your application. We have package managers as well, if manual installation isn't right for you. And then dig into the samples and the dev labs. I've talked about both of them already. They'll get you, once you've got the runtime into your project, they'll get you started on using bits of functionality. If you're building a new project from scratch, consider these other options as well. IDE templates, I mentioned Xcode doesn't really allow that, but where we can allow it, we provide templates. The guide docs, again, for integrating the SDK, and then example apps, dev labs, and samples can all come in useful when you're building a new app. For example, you could find that one of our example apps is the perfect foundation for you to start your application. Lastly, just very quickly, what's next? So update 2 is coming in December. The major focus there is for more offline capability, particularly offline analysis. We're going to be introducing service area and closest facility tasks to go with the offline routing that's already available. There'll be line of sight and view shed. Now these, where possible, we take advantage of the GPU on the device. So we get extremely high levels of performance there if the analysis is appropriate for that. GPU is really good for things like view shed. We are introducing more offline data sources. So you can put shapefiles and geo packages directly on the device and be able to open and work with those. We're introducing time awareness to the SDK, so your time aware layers can be fully made use of. And we're introducing electronic navigation charts. Now, I'm just going to mention update 2.1, which will be coming early next year. There were certain things that we really wanted to put in update 2. We're not going to be able to do it. We didn't want to delay update 2 because of it. These are things, just augmentations to update 2 that we think you're really going to like. Here's an example of the S63 encryption standard on ENCs. So that'll augment ENC introduction of update 2. There's a lot of other stuff coming in update 2 too. This is just a quick overview, a little highlight. Beyond update 2, we're going to be working more on the toolkits as well, expanding those, things like time sliders, and tables of contents, compasses. Now again, these are open source on GitHub, so you can take inspiration and start to build your own components that would work with those. Where we're lagging on a particular framework or another, because it's open source, maybe you can see another platform and be able to implement something that'll work for you in the meantime. And the very last thing I want to mention, we're looking at augmented reality and virtual reality with the runtime. If you're interested in building an AR or VR solution using the runtime, please drop us an email at ArcGIS Runtime AR/VR beta@esri.com. Bit of a mouthful, but drop us an email and we'll get back to you. We're really looking forward to seeing what kinds of things you might be looking to build using AR and VR and GIS with the ArcGIS platform. With that, that's all we've got for you. Thank you so much for taking the time to listen to us today. And I think we'll hand back to Amy for some Q&A.
Thank you, Nick. We're now going to begin answering the questions submitted during today's presentation. As a reminder, you can still submit questions through the questions pane in your attendee control panel. Our first question is, are you planning to redesign the API as the JavaScript API style?
Okay, I muted myself there, rather silly. No, and I think looking at that question, I think it came in the context of the JavaScript samples that are available through the developer's website. And it's true that the samples, the great thing about the JavaScript samples on the developer's website is that they're interactive, and you can pull them up in a sandbox environment, make changes to the code, and be able to do that. Now, I do point people developing for the runtime at the JavaScript API, because a lot of the patterns, the platform patterns that are introduced in the JavaScript API are reflected in the runtime as well. If you're doing a geocode or a routing task, the patterns are very similar. We don't have the same unification that we do across the runtime SDKs, but it is close enough that if you can pick up the JavaScript pattern, the runtime patterns should not be strange for you, and vice versa. If you're a runtime developer, you should be able to go to the JavaScript API. But in terms of actual getting more integrated than that, then no. However, if there are specific areas where you see misalignment, I mean, please let me know. I spent a little time looking for this. I don't see many instances, to be honest.
All right, the next question is, does ArcGIS Runtime replace Arc objects?
That is an interesting question, a long question. No, so Arc objects is really used within the context of ArcMap for building extensions to ArcMap. ArcEngine was the kind of presentation of Arc objects to build independent, standalone native applications. In the context of ArcEngine, our goal is to provide enough functionality for most people to be able to re-implement their ArcEngine work, or to take on new projects where they might have considered ArcEngine previously and do it with the runtime. So we're not quite there yet, but we're really, really close now. It's been a long effort, and we are close, but there are some things that ArcEngine did that the runtime will probably never do. And Rich, I don't know if you have any other insight that you want to add to that.
No, I think that actually covers it pretty well, what the landscape is.
Yeah.
Okay, this question was for Rich. Rich, what program was it that you were using during your demo with the emulator?
That is I assume the live coding demo, the text and code snippets. That's a program called Xamarin Workbooks, and you can find that on Xamarin's website.
Perfect. How rich is the symbology capability in ArcGIS Runtime? Since Runtime supports the development of thick client apps, can I use the full capability of cartographic symbology on apps built using ArcGIS Runtime?
Rich, do you have any insight on that? I'm not involved in the symbology side of things too much.
There are. It is not as rich as the full suite of symbology capabilities you get in ArcGIS Desktop. It's pretty good and pretty flexible, and that's actually getting quite a bit more and closer to what you can do in, say, ArcGIS Pro at Update 2, which introduces something called multi-layer symbols. There are still certain things that you can do in Pro that you can't yet do in the runtime, but you can get a lot of the way there, and even more of the way there Update 2.
So the only thing I'll add to that is that I know there's work to flesh out an API to be able to control that more advanced symbology. So for example, if you're exporting something from Pro, the runtime will support it, a lot of it right now, not everything, but a lot of it. But there isn't actually an API to manipulate that symbology yet. So I know that's on the roadmap. And if you're little sneaky deep dive, since we promised some deep dives, there are ways to generate symbols from raw JSON. So if you really know what you're doing and you dig into some of the output from Pro, you can take some of it and create symbols using just JSON that represent some of the more advanced stuff.
Okay, great. And this is a question for Nick. How can we get the code snippet that you were working with Workbook Coding 101? Nick's code.
Yeah, I will have to share that out. I presumably we could put that out there on GitHub, or we can follow up with attendees and send it directly. I'm not sure exactly what the proper repo for that would be, but we can definitely get it out there.
Okay, great. You've mentioned the high performance for ArcGIS Runtime several times. What makes it so much more performant than other Esri APIs?
Well, I don't know that it necessarily makes it more performant, but the reason I mention it is that I want to clarify that as a consumer of the runtime, rest assured that one of our foundational goals for building the runtime was to give you the best performance out of the device that you can get. So, for example, where we can use the GPU, we do. The C++ core runtime is optimized to work really, really well across devices, across the SDKs. I'm not sure that I would say it's necessarily better than the other solutions, but it's if you compare it with Engine, for example, it uses more modern design patterns and the like. So there may be aspects where it's better performing. There may be aspects where it's the same. Rich, I don't. As a developer on it, maybe you've got some insight too.
Again, I think that pretty well covers it. I mean, there are certain things you can do with the runtime, such as the offline capabilities we talked about, that for particular use cases, you may see better performance by virtue of removing network latency that you might not be able to do, say, if you were trying to do the same thing with a web API. But yeah, aside from that, I mean, I think you pretty well covered it, Nick.
Okay.
Okay. Can you edit local data without a feature service?
Not yet, but well, actually, or is that may be true with locals? Are you able to do that with local server, Rich?
You can do it with local server.
Yes. So on certain platforms, I think if you're, correct me if I'm wrong, if you're targeting Windows or Linux, so you're using the .NET or the Qt or Java SDK, I think you get a component called local server at certain license levels that allow you to essentially keep data offline, serviced up. The runtime sort of consumes it as a service, but it's all handled locally on the device. But again, that limits the platform you're targeting. We're looking into expanding that, but right now that's the limitation.
In what format are the base maps offline? Do you need a TPK hosted somewhere or just a hosted base map?
For offline base maps, you can do a couple of things. So you can, if you've got a hosted base map, ArcGIS Server, ArcGIS Online allows you to take a section of that offline. If it's an imagery base map, you can do that right now. If it's a vector tile base map in ArcGIS Online, you'll be able to do that soon. So specify an area, say I want to take this offline from there. Or you can use something like ArcGIS Pro or ArcMap to generate a TPK and then load that onto your device. So depending on the platform, you load that onto the device differently, but that then becomes a local file on the device which you just access from the runtime.
Does this require the service to be off SDE rather than an FGDB for offline capability, similar to what Collector requires?
Good question. I don't know, but I suspect that if Collector requires it, since Collector is built off the runtime, then the same is true for the runtime.
Yeah, as far as editing capabilities, if that's what that refers to, then yes, I'm pretty certain that that requires SDE on the back end.
Okay. Well, thank you, Nick and Rich, and thank you everyone for attending today's webinar, Building Native Apps with ArcGIS Runtime. If you have any other questions, please contact me using my email address in your follow-up email. If you did submit a question that did not get answered, please rest assured that Nick and Rich will be answering those questions in a follow-up blog post that will be located on GeoNet under the Geo Developers group. On behalf of Esri and our presenters, thank you for joining us today, and have a great rest of your day.